Hello, this is my English speaking practice. Today's problem is N queens. The N queens puzzle is a problem of placing N queens on a N by N chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the N queens puzzle. You may return the answer in any order. Each solution contains a distinct board configurations of the N queen's placement, where Q and dot both indicate the queen and the empty space respectively. Here is the example. When the n is 4, we have two answers. There exist two distinct solutions to the 4 queens puzzle as shown above. This. The queen can move vertically and horizontally and diagonally. So yeah, displacement, each queen cannot attack no two queens attack each other, right? Okay. So we are given n, and basically we have to going to place the queen one by one. I think so. Choose here. Try to place here at first, and in the row we cannot place more queens, so we are going to the next row, and here is also not allowed to place, so going to here. This is also not good because it's on the diagonal line of this queen, so we are going to place here, and this is not good. This is also not good because there is a queen on the diagonal line, and this is not good because it's on the vertical line, and here is also not good diagonal line. So for this row we cannot place the queen, and at that time we can find out this pattern is invalid because the board size is n by n, and we have to place n queens, so each row must contain one queen. So at the time this attempt is not going to be the answer, so go back to the first, right, and press here for next, and here is good, here is not good, here is not good, so we press here. And how about this? This is also good, and here, this is also good. So this is the one of the solution. This is a basic algorithm to solve this problem. Yeah, so so the problem is how to check if the placements are allowed or not, right? We are going to look at each row. So for horizontal direction, we can do it easily, and the problem is for diagonally. Let me see the n size of n. N is not too big, okay? So we can have the set of the position column number where we have already placed the queens, so we can check it easily for vertical direction. Yeah, so the yeah, let me see the diagonal line or not. Diagonally and diagonally. So we let me think about this case. We have already 2 queens on the board, and we are try to place queen here, and we already checked the vertical line and horizontal line. Yeah, so all we have to do is check diagonal line, and we have information about the positions coordinates where we have already placed the queens, and how to find out that is on the diagonal line or not. Okay, I see. It have same y difference and x difference, right? So this case, for this queen, we have to placement on this line here and here. So the distance for x, 1 minus 1. For y, 1 1. Okay, so we don't need to care about sign. We can use absolute value, so 1 1 1 1. Okay, so if they are the same, it means the place is on the diagonal line, so we cannot place the queens on it, right? And for placement, we have to check all possibilities. So the most, I want to find the most easiest way to check it. I think we should think about, we should think the distance from this, and for example here is 30 or 03. 30, yeah, no, 220, yeah. Row is 2, column is 0, row is 2 and column is 0, and we have to check one by one. Yeah, but for below area, we don't need to check it because we haven't placed the queens that area. So here is 20, right? Board 20, so should check going to decrement one by one, and so check 1 1, right? And possibly 1 minus 1, but this, if it is less than 0, we don't need to, right? And so this case, check 1 1 and 0 2. Okay. So for y coordinate, we decrement, and for x coordinate, we increment. We both increment and decrement by 1. But if, as long as they are more or equal to 0, that is a valid position. So the positions to check is these two positions, right? That means here and here, right? And we don't have the queens on the line, so we can place, right? Think about this. This is also 3 positions to check, and here is good. But this is not good vertically, and here is not good vertically. So here, vertically good, horizontally good, diagonally good, right? So we can place it. And yeah, if we can place all n queens, that is the answer. So yeah, we just put it as answer. So I think we can solve this problem by DFS, depth first, or backtracking. Because if the path is not good, we have to go back to some point and restart to explore the path. So backtracking works for here. And let me think about before coding, we have to think about the complexity, time complexity and space complexity. Time complexity, that could be so big because because when we place first queens here, we have 4 options theoretically. Yeah, of course here is not good, obviously, but theoretically we have 4 options. It is size of n, right? No. We have 3 options basically, and 2 options and 1 options. Alright, so it's so we have 4 options, 3 options, 2 options, 1 option, right? Factorial, yeah. Factorial, basically factorial. And for each placement, we have to check the validity, horizontally, vertically, diagonally. Horizontally, we don't need to do that because we make sure if we placed one queen on the line, we move on to the next line, so we can make sure it is horizontally safe, right? So we don't need to do that. So it's it doesn't take the time complexity. And for vertically, we are going to use the set. So for checking if the placement coordinate is in the set or not, can be executed in constant time. So yeah, it doesn't affect to the time complexity entirely. For vertically, as we see, we check one by one. So it is a linear algorithm, right? If we place queen at last here, we have to check 3 times, right? So it is how? So for the first row, we don't need to do that, and so second row we have 2 room to check diagonally, right? And for here we have two row, so the number of row to check increase one by one. And yeah, so how to so let me think. We have 4 options at first, and in this case we don't need to check diagonally, so 4 by 1. And for the second row, we have 3 options because we have already one queen. We have already placed 1 queen, so we have 3 options, and we have to check it diagonally, and it takes a cost. This is one. This is still technically this is 0, but it's not 0, right? You know. Yeah. So let me do it as it is 1. And for row second, yeah, regard this as 0. Yeah, technically here is 0, but for simplicity, we will regard as 1, right? And for the third row, we have 2 options, and we have to check right. And 1 and 3. So it is like this, I think. We can regard this as like this, and 4. But we can regard this as factorial, I think. So the time complexity is Tc of n factorial, right? Space complexity. Basically, we can solve this backtracking with backtracking. So we don't need to extra memory space. It just use the call stack. But it uses set. So of n. Y direction, X direction. Okay, let's code it. Let's code it. So for X direction. This is used for vertical check, and this is used for diagonal check. Right. So row is we have to okay. So this should be list str, and we are going to be building these strings, and yeah, so the row and column. No, we have column. Yeah, I think this is enough, and the row start with 0. So if row equal to n, that means all done. So return and we have the global list that is called ans. So the placed, this represents the strings, represents the this list of string represents the board that we have finished placing n queens. So here is the base case, and otherwise we are going to place the queen on the row, specify the row. We have to check all of the column. It would be range n. Range n. And it might be so it means vertically. Check. So it means the column we are going to place, column where we are going to place it is in the XS, means we've already placed on that column, so we do nothing. We don't move to next, so we just continue the loop. Otherwise we can place it. So that means construct the row, right? How to construct? If the column is 0, right? N minus -1. Yep. Here is the new row string. So we append the row string to the placed. Oh, no. We have to check diagonally. Can I? Check here. So if the row is 0, we don't need to, right? Row is 0, we don't need to, so it's basically it should be range row. If it is 0, we don't need to. If it is 1, we just check 1. Means y should be row minus d. And we have two possibilities, x1 and x2. That is right? Yeah. But it is it might be out of range. So yeah, y is safe. Y is safe. x1 and x2 might be out of range. So if x1 placed y x1 is q, it's we have valid flag, it is true at first, and if the x is valid and that point to the q, it's not good. So we have two options to check. And yeah, if after the loop we check we should continue the loop or going move on to the next. And vertically check, if they are passed, we construct the new row, new strings of row, okay, like this, and place it, right. And backtracking, right? rho plus 1 xs means xs add column xs placed, and after that we have to pop. Here is a backtracking. Remove column. Yeah. Zero. Set the empty list. Returns. Let me see. Out of range. Where it is, where it is. It starts at 1. Yeah. If row is 0, upper no max row, right? If row is 0, the upper should be 1, right? 1, 1. No. How to if the row is greater than 0, we have to diagonal check. Have to do the diagonal check. Alright. Wrong answer. Why? 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 We have to copy it. The wrong answer. 2, 3, 4. Second, fourth, first, third. Second, third, first, fourth. Second, third. Second, third. Oh, that's not good. Why it become possible? This is also not good. Why? Oh, wait. Row. +1, right? When the row is 1, it should be 1. When the row is 2, it should 1, 2. Okay. Okay. Let me do it with 9. Great work. Not bad. Not bad. Zero. Diagonal. Two diagonal line. Row plus. I see. So if we think about this diagonal line. 0, 2. Huh? 1, 0, 1. Yes. 1, 2. That is 3. 2, 3, 4. Huh, 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 huh. 0, 1. 1, 1. 1, 3. What doesn't make sense? R minus. Zero, 1. Row minus. Row 2, column 2. That is 0 and 4. 0 and 4. 0. 0. 0. 4. 4. 4. Oh, I see. I didn't know that. Makes sense. So for row minus column means same line from top left to bottom right, because it means for this example same row and same column, so the difference is 0 for this line. For this line, I think row is 2, 0, 1, 0, so 1. Difference is 1. Difference is 1. Difference is 2. Difference is 3. Exactly. And for this direction, row plus column. 4. 2 plus 2. 1 plus 3. 0 plus 4. 0 plus 3. 3 plus 0. I see. Makes sense. makes sense. Yeah, this is simpler than my solution, but yeah, essentially same. Okay. Yeah, that's good. So let's call it a day. Thank you for watching.